Hi, Tim with Stromquist, here for another segment of Tim's Tech Tips. Today I will cover cooling tower temperature control using a Honeywell frequency drive and a Honeywell T775 controller. We'll be looking at wiring, programming, and application. So let's get started. First of all, we'll have my frequency drive. This frequency drive will be being controlled by my temperature controller, the T775M control. The frequency drive will have an analog input driven from the analog output from the T775 controller. This will be a 0 to 10 volt DC signal. I'm going to have a digital input, which is my run stop signal. That's coming from a digital out relay from a controller. The controller is looking at a sensor. Then I'll have one final part, which is a digital input to this controller. What this digital input is just a set of contacts. It's a thermostat switch, whatever, coming from your facility to determine econo or mechanical cooling. All right, I want to show the wiring, again the programming, and we've got the application here. Bottom line, this is important because when you're controlling your cooling tower fans with the frequency drive, you'll have a certain set of temperatures, set points for your mechanical cool, and then a different set for your economizer. That's what's important to keep in mind when we're doing this setup. So let's take a look at what we have here. Okay, let's take a look at our wiring. Now I have a lot of wiring that we need to ignore because I've got a lot of switches and lights in here. All I'm really looking at in this application is what I've drawn on the board. I've got my analog input, which is coming from my analog output from the controller here. I've got my digital input right over here, which I'm wiring from my relay, and then I've got a temperature sensor right here. Now I've got everything powered up, ready to go. First thing we need to do is set my frequency drive up. So I'm going to actually wipe all settings from this, so we start from scratch, and I'm going to restore this to factory defaults like it comes from the factory. Okay, we're going to go through a little reset. And then answer a few questions. Right here it's asking for the language, it's English, daylight savings, we're in the US, time zone, and also date. I'm not going to actually put in the date because that's irrelevant to this application. And it says, do we want the startup wizard? The answer is yes. S, is it a fan or a pump? I hit OK for yes, and then it asked me for the RPM. 1750 is correct. Asked me for the amps, and it's for the motor that's actually in our simulation, and that is our setup. So about 30 seconds, we have just now set this up to receive a 0 to 10 volt DC signal from this controller. All right, now we need to set this controller up. So we're going to hit Menu and then Program. To hit Enter, you do the right arrow. All right, Mod 1, that's modulating output 1. That's this output right here. So we'll hit the right arrow to hit Enter. The set point. Right now I've got 77 degrees. I can raise or lower that. We can just, let's just change that to 78 degrees. So that's my set point. I hit the right arrow to accept that. Then my throttling range, 5 degrees. You can kind of tweak this to set, so it'll be right for your facility. I think 5 is okay here. Then it asks for the sensors. This, you can input up to 2 sensors on this. That's this sensor right here, and that's sensor A. And then it asks if I want this to operate as in heat or cool mode. We, of course, want cool, so there that is. And then this is important. It's asking for the setback. If you want to have an economizer mode of operation, you will need that. So we're going to say the setback is, temperature is going to be 46 degrees. Enter that and then exit. Now it goes to modulating output 2, which we're not going to use. Drop down to relay number 1. Hit that. Set point, I've got that set at 70 degrees. Which is, so what that is telling me is when this sensor senses 70 degree water, it's going to open that relay. That relay is this relay right here going to my run stop on my drive. So that's an important set of contacts here. So my set point again, 70 degrees. So if it goes below 70 degrees, my relay contact's open, shuts my drive off. That's when I'm in mechanical cooling mode. Okay, let's go now the differential. I've got a fairly tight differential. We can hit that to 2 degrees, but I want a fairly small differential here on this relay. Sensor, you can have 2 sensors, A and B. I've got it in the A slot, so I accept that. Again, heat and cool. I select it for the cool mode, and then the setback, I've got 43 degrees on that. Let's exit that, and we're ready to run this program. So it's very quick, simple setup on both of these devices. Now let's get it ready to run. My temperature sensor, we're going to be simulating water temperature. So I put in this cup of water. Let's see what our temperature is going to be. We're at about 69 degrees. And it's warming up to 70. I've got some hot water. And you notice that my cooling tower motor is not running. It's not going to run until we warm that water up a little bit. All right, we warm it up. It's warmed up to 74 degrees now, 77, and you see as it gets warmer, our motor will spin a little bit faster. We're at 39 hertz, 43, and it's going to spin on up to 60 hertz to try to maintain set point. Ramping on up. Now, I can cool this water down. All right, temperature's dropping, fan speed is dropping. So, and if we drop below our low limit, which is for this digital output, our relay output, it cuts our motor totally off. We're real close to that right now. We're sitting at 70 degrees. And just one more second, it will cut the motor off altogether, and it just cut off. So that illustrates ramping up, ramping down the motor based on our set points for mechanical cooling. Now I've got these contacts right here. This is for our changeover from mechanical to economizer, so let's flip that right now. And of course, if we do that, we're going to have pretty cold water, so I'm going to move our sensor over to our ice water. And of course, while we're in mechanical cooling, the fan's not going to turn. Now I'm going to switch over to economizer, water side economizer mode, and you notice it is ramping our fan up. We need to bring it on above our set point, and you see we are pretty cold right now. It's ramping our fan up to cool our water down for economizer, water side economizer cooling. If the temperature drops too low, it'll turn the fan off. Again, you can change our set points, change your setbacks very easily to make it do whatever you need to do for your particular city, your circumstances.
If you need to control it or measure it, Stromquist & Company has a control solution for you. With over $2 million of inventory between our Georgia and Florida locations, an easy-to-use online ordering platform, same-day shipping, and a factory-trained team of controls experts to answer your questions, Stromquist & Company continues in its tradition of offering great service and great products.